Hey class, factoring and solving day one. So hopefully you've got a good grip on factoring by now, and now we can use factoring to help us solve some quadratic equations. So just a quick review of factoring. First, sometimes all you can do is factor out what we call the greatest common factor, the highest number of variable that divides into each term. Especially if it's just a two-term binomial is what we would call this. If it's just two terms, a lot of times the only thing you can factor it is by taking out a greatest common factor, unless it's one of those special products like difference of squares, difference of perfect squares, which this is not. So the highest number you can divide 5 and 10 by is 5. The highest variable you could divide by here would be x cubed. So if you take out a 5x cubed, that means you're dividing each of them by 5x cubed. So here, the first term, you would be left with an x squared, and then plus 10 divided by 5 is 2. X cubed divided by x cubed is 1, so it would just be 2. And remember, you can always double check your answer when factoring by multiplying it back out. In the second one, the highest number that everything is divisible by is 2 again. And then since each one has at least an x, you can divide by an x as well. So dividing each of these by 2x would leave me with 2x squared minus 2 divided by 2 is 1. And then x squared divided by x is x, so 1x minus 1x. And then negative 6 divided by 2 is negative 3. X divided by x is 1. So that would factor there. Now to see if this factors any further, a quick way to check is just to take the first and the last, multiply together, makes negative 6. And then can you find something that multiplies to negative 6 but adds up to negative 1? So it's negative 1 and 6, negative 2 and 3. Well, if I reverse this, actually negative 3 and 2, this adds up to negative 1. So that means it does factor more. So you have 2x squared and negative 3, or in our parentheses we have a 2x times an x, and then we need a negative 3x and a positive 2x on the outside and the inside factors in order to add up to the negative 1x. So if you use the box, it really organizes the work nicely, because then you can see, this column has a 2x in common, so 2x goes up here. Then 2x times x right here makes 2x squared. Then x times negative 3 in this spot makes negative 3x. And 2x times 1 is 2x there, which means it would be 2x minus 3 and x plus 1 as our factors, which you could double check by multiplying the outside together, and that's 2x. And then the inside together, that's negative 3x, and that does add up to the negative x in the middle. And we know that on the ends, negative 3 times 1 would give me negative 3. All right. I'm going to do one more factoring just for review, and then we're going to move on. So the first one here, you can factor out a 2. So then I have x squared plus x minus 6. This one's easier to factor because it's just x squared, so I know it'll be x times x. I don't even need a box for this one because multiplies to negative 6, adds up to positive 1. It's going to be kind of similar to the last one, but it's negative 2 and 3. So negative 2 plus 3, because it's just x squared, these are our factors, negative 2 and 3. Okay, so factoring and solving. The zero product property says that basically anything times 0 is 0. So if I have like A times B equals 0, then it tells me that either A equals 0 or B equals 0 or both equals 0, because anything times 0 equals 0. So when you think about that with factoring, let's do the first one here. So it's equal to 0. So 2x cubed minus 18. First, take out a greatest common factor of 2x. That leaves me with x squared minus 9. Now, x squared minus 9 is a difference of perfect squares. It's x squared, so it's x times x. Multiplies to negative 9 and adds up to 0. That's positive 3 and negative 3. So here, essentially, we have an a factor, a b factor, and a c factor. So that means that either a equals 0, b equals 0, or c equals 0. Because if a equals 0, then a times b times c would all be 0. If b equals 0, then a times b times c would be 0 again. Same with c. So you really have three possibilities that would make this equation true if either one of these three factors was equal to 0. So in the first one, solving for x, you divide by 2 on both sides. X equals 0 is one answer. The second factor, you subtract 3 on both sides, so x equals negative 3 is the second answer. And the third answer, you add 3, so x equals 3. So you have three answers here. Notice it was a cubic, x cubed, so three answers make sense. 0, negative 3, and positive 3. So those are your solutions because those would make the equation true if you plugged it back in. Okay, for this one on the right here, take out the greatest common factor. You can divide both by 3 and you can divide both by x, which means that you'd be left with an x minus 5. It does not factor any further since x minus 5 is linear now, which means it's just an x. So this is like your a and this is like your b. So either you have two possibilities to make this a true equation. Either 3x is going to be 0 or x minus 5 is going to be 0. So solving for x in the first one, your answer is x equals 0, and solving for x in the second is x equals 5. So if you plugged in 0 or plugged in 5, they would both make the equation 0. So those are your answers. So first, if you want to solve by factoring, you got to factor it. I know it's an x squared, so that's an easier one to factor. It's x times x, and then you just find multiples of c, so negative 15 that add up to negative 2. That'd be negative 5 times positive 3. That means your factors, this only works this way when it's just an x squared, remember, but your factors are going to be x minus 5 and x plus 3. Then you take and set each factor equal to 0. So either x minus 5 equals 0 or x plus 3 equals 0. So x equals 5 and x equals negative 3. For the one over here, you can do the same thing except for that if you want to use the zero product property, your equation does have to be equal to 0 before you can factor it, which means that you will need to start by adding 30. Since 30 is not like an x squared or 11x, you're just going to add it to the end. So write it in standard form, highest exponent term to the lowest exponent or to the constant. And since this is x squared, I know it'll factor to x times x. And I just need factors of 30 then, that'll add up to 11. That's going to be 5 times 6. They're both positive since it multiplies to positive 30 and adds up to negative 11. Then set each factor equal to 0 and solve for x. So x plus 5 equals 0 means x equals negative 5. If x plus 6 equals 0, then x equals negative 6. Couple more. In the first one in example 5, we have to make it equal 0 by subtracting 21 from both sides. So we get 2x squared minus x minus 21 equals 0. Unfortunately, there is no greatest common factor to take out, so factoring this, you can either do the guess and check method or you can use the box to help you out. If we use the box, then we put the 2x squared here and the negative 21 here. Then you take the 2 and the 21 and multiply together. That's negative 42. And remember, you want this middle column to equal negative x. So you multiply the 2 and the 21 together and get negative 42. Then you need factors of 42 that are going to add up to negative 1. So 42 is 1 and 42, 2 and 21, 3 and, oh, I know 6 and 7, 3 and 14. 4 doesn't work, 5 doesn't work, 6 and 7. And 6 and 7 are the two that I can make negative 1 with. If I make the 6x positive and the negative 7, or the 7x negative, then that'll equal negative 1. Okay, so figuring out the outside then, 2x squared and 6x, the 2x goes here in that row, and that means that 2x times x is 2x squared, 2x times 3 is 6x, and x times negative 7 is negative 7x. So the outside of the box multiplies together to give you the inside of the box, basically. So then your factors are x plus 3 times 2x minus 7. And then you can solve those. X plus 3 equals 0, or 2x minus 7 equals 0. So x either equals negative 3. This one you do need to do 2 steps. You need to add 7 and then divide by 2. So x equals 7/2, which would be 3.5, 3.5. All right, one more. So first we got to get it equal to 0. So I'm going to subtract everything over and then make sure to combine like terms. So minus 2x squared on both sides. It's a negative 8x, so add 8x to the 5x, and then minus 1 from the negative 4. So that's going to give me 6x squared. 5x plus 8x is 11x, and negative 4 minus 1 is negative 5, equals 0. So no greatest common factor, so I can jump right to factoring. 6x squared and negative 5. I need my middle to equal 11x. If I take factors of negative 30, which again is by doing 6 times negative 5, and I need to find something that adds up to 11. So like 1 and 30, 2 and 15, 3 and 10, 5 and 6, and 5 and 6 make 11. Since it multiplies to negative 30, though, one of these would have to be negative, so that doesn't work actually. 5 and 6 does not work. 8, 9, 10. Oh, pardon me, I have a mistake here. This should be 13. 8 plus 5 is 13. Which means that 3 and 10 work. Nope, still don't work. Struggling. 2 and 15 work because it's a negative 30. So I want to make 13x, so it has to be positive 15 and negative 2x. Sorry, apparently I should have practiced this one first. Okay, so figuring out the outside, if you look at this column here, 2x and 6x both can be divided by 2x, and then 2x times 3x is 6x squared in the first box. Then 3x times 5 is 15x, and 2x times negative 1 is negative 2x. And then the last box here, negative 1 times 5 is negative 5. So that works. So your factors would be 2x plus 5 from the top, and then 3x minus 1 from the side. Which means that if I wanted to solve this, set each of these factors equal to 0 and solve. So two-step equations. First, on the left, minus 5, and then divide by 2. So negative 5/2. Or on the right, start by adding 1. 3x equals 1. Divide by 3. X equals 1/3. So those are your two answers there. All right, give it a shot. let me know if you have some questions. I expect questions, so let me know.